To study the photoelectric effect, an experiment was done by Hertz and Lenards. Helveg, Lenards and Hertz were the scientists who were doing many experiments and drawing results. So the famous experiment for photoelectric effect is seen in this diagram. One evacuated glass tube is taken. This is the glass tube, and here it is closed. This is a quartz lens. Here is source of light, and from here the light can enter from this quartz, and it is a photosensitive plate. This is a metal plate on which the light is falling, and here is another plate, and we connect it outside. Now we want to study how much current is flowing in this and what is the potential difference between the two, and for this arrangement we make here this arrangement. There is a battery. From this, between these two terminals we supply the potential difference. This potential difference can be adjusted from this rheostat. And how much is the potential between these two electrodes? For that we fit a potential difference here. Voltmeter, and this voltmeter will tell us the potential difference. Similarly, see the path of current. When the current flows, it goes here, then it will go either in this direction or it will go in this direction. So this is a commutator. This commutator will rotate it. In a commutator, when these two are connected with this two, then this will be positive. This is positive. But if we are using this and turn it, then this is connected with this and this is connected with this. So this is now negative. So this way this commutator can make it either plus this way, or it can make it minus this way. This way. Minus. And if it is connected here, then it is plus. Okay. So this is commutator. How much is? Okay. It goes from here, and here we find the current between the two, potential difference. So this is an arrangement done. This is a evacuated one, so that there is no other gas or air except the electrons which are given by this plate, metallic plate. Now from here we give the light. The light which is incident on the plate, we want to study its two properties. And first you must be introduced with these two properties, and these properties are intensity of light, and other is frequency of light. Intensity of light, लाइट में कितनी एनर्जी है, तो लाइट की एनर्जी उसकी चमक से हमको पता लगती है. इन वेरी सिंपल वर्ड्स, यू हैव सीन द बल्ब्स. 20 वॉट का बल्ब, 20 वॉट बल्ब, 40 वॉट बल्ब, 80 वॉट, 100 वॉट बल्ब, 200 वॉट बल्ब. What is the change? The change is in the intensity of light. तो वॉटेज चेंज करने से, पावर चेंज करने से क्या चेंज होता है? आंसर, इंटेंसिटी चेंज होती है. इफ आई टेल यू दैट दिस इज ए 100 वॉट बल्ब एंड दिस इज द लाइट कमिंग फ्रॉम इट, प्लीज डबल द इंटेंसिटी. व्हाट यू विल डू? यू विल फिट ए 200 वॉट बल्ब. इंटेंसिटी डबल हो गई. 5 times 500 watt bulb, intensity has become 5 times approximately. So that is how we change intensity, and that is what is the meaning of intensity. Now frequency. So intensity of light, will be given by power. Frequency of light. Whenever there is a change in the frequency of light, there will be change in its color. Yes. Red to blue, there is a change in wavelength. The velocity of light is same, so frequency is equal to C upon lambda. Lambda is different for different colors, so frequency is different for different colors. So here we say that we are changing frequency. What does that mean? We are changing color. But color we are using only for visible light. The light may be infrared, less frequency, or it may be ultraviolet, a larger frequency. So the frequency changes. We can use the radiation of heat, infrared, visible light, more frequency, ultraviolet, X-rays. So we can use any radiation from this source. But in general terms, in visible light, frequency changes by color. So if I put yellow light first and then I put blue light, what I have done? I have changed the frequency of light and I have used larger frequency, more frequency, because blue is having a larger frequency compared to yellow one. Okay, that is frequency of light. So here this source is variable. If I want, I can change intensity of light. If I want, I can change frequency of light. If I want, I can change the both. Okay, so this is our arrangement, and now we start practice. We will see the different results and we will try to make out why this result has come. First, for a particular light, for a particular frequency of light, whenever we are starting light from here, the light is incident on this plate, we find there is certain current in the circuit. We note down the current. Okay, so intensity of light is this much. We see the current is this much. Again we double the intensity, the current also doubles. 3 times the intensity, current is 3 times, and 10 times the intensity, current also become 10 times. And this relation is a linear relation. So this linear relation, what does it tell us? This tells us that intensity and photoelectric current is proportionate to intensity of light. More is the intensity, more will be the current. Okay, logical, we got it. Now, what is our conclusion with that? With the help of wave theory, we can say if the intensity is more, then amplitude is more. The wave front amplitude is larger, therefore energy is more, and therefore current is more. Photon theory, what does it say? It says larger intensity means more number of photons. If a 100-watt bulb is sending 100 photons per unit of time, 200-watt bulb is sending 200 photons. So more will be the energy, and because of that more will be the current. Both agree, both gives the same result. Okay, it's fine. Now we change our experiment and we go to the second mode. The second mode is, now we are observing we are giving a potential difference between these two plates. This was without potential difference. Or keeping the potential constant. Now we are giving a potential difference between these two, any one potential difference, and start the current. And after that we increase the potential. First, this is plus from 0, plus 1, plus 2, plus 3, plus 10, like that, positive side. Then we make it minus 1, minus 2, minus 3 on negative side. See the effect on both sides. Effect on what? Effect on current. What we are changing? Potential difference between the two, and what we are observing? Electric current. Okay. Here we keep one intensity, say 100 watt bulb. No potential current is this much. This is photocurrent and this is the value of current. Now we increase the potential, the current increase. Again current increase, and after some time the current become same, that is saturated current. Okay. This is when we increase the potential. Now when we decrease the potential, what happens? Here, if this potential was 0, there was a certain amount of current. When we make it minus 1, what will happen? This is 0 volt, this is minus 1 volt. When an electron is ejected from here, why the electron is ejected? Due to this light. The light gives energy to electron and the electron is ejected because the light gives it energy, and that energy is more than the work function. This we have done in the previous lecture. If this energy is more than the work function, then this is ejected and it has got kinetic energy. Okay, if it has got kinetic energy, it will go in this direction. But if we give it minus 1 volt, see both the cases. If we give it plus 1 volt, then this minus is attracted by this plus and it will move fast. So the current will slightly increase. But if it is minus, then there will be a repulsion. From here, there are 100 electrons going out. All are not having similar energy. Some have got energy level 10. Some have got energy level 5. Some have got energy level 1. I will tell you the reason for that. Why they are having different level of energy. But there is a different level of energy with these electrons when they come out. So this minus 1 is sufficient to stop the electron with less energy, minus 1 energy. They stop. But other which are having more energy, they will go. We increase this. So what will happen to the current? The current will decrease but not become 0. It will become a little less. The current, this current will become little less. This much only. Again we make it minus 2 volt. When we make this minus 2 volt, this is minus 2 volt. Then the electrons with energy minus 1 were stopped. Now with energy minus 2 are also stopped because the repulsion by minus 2 volt is very large. So that will also stop. So the current will reduce further. Now we give it minus 5 or minus 3, more stop. So by this way we go on increasing this negative potential. There is repulsion more and more. Or we can say there is supply of negative potential energy, because potential energy is what? Q into V. Here the charge of electron is minus E and the potential is what we are supplying here. So it has energy negative. Now if electron has energy to go plus 10 and we are supplying here minus 2, So this energy remain 8. 10, 2 minus 8. Now, if some electron is having energy only 2, then this minus 2 makes it 0. The electron will stop here, it will not go. Now, if I increase it to minus 4, then this will give it energy, how much? Negative energy. That is minus negative energy. Okay. So, this will be potential energy given to electron, and that will stop. The electron which have got energy 4. Okay. Now, this minus is always repelling this negative. When I increase it up to 6, I find very small current. And when I make it 7, it stops completely. So, that situation happens. I decrease the voltage. I decrease collector plate potential. Then the current also decrease. Decrease the voltage, current also decrease. Decrease the voltage, current also decrease. And at this particular voltage, the current becomes 0. The photoelectric current height has become 0. This voltage is known as stopping potential. Okay, this was for a particular bulb, say 100 watt bulb here. Now I put here 200 watt bulb, but I do not change the frequency. If it was a green bulb earlier, now again it is a green bulb. But the potential is 200 watt, power is 200 watt, so intensity of the light, it increases 2 times. Again I start with 0 volt. I find there is a current, but that current was slightly more than the current of 100 watt. Here, this current is slightly more than the current of 100 watt. This is 200 watt from here. I increase the voltage between the electrodes, so the current also increase, and then it becomes saturated. Okay, now I give it reverse voltage. When I give it reverse voltage, this minus will repel it. When it is repelled, the number of electrons decrease, the current decrease, and I find the current is decreasing. Again, minus is increased, so more electrons are stopped, the current becomes still less. More negative voltage, there is more reduction in the current because the electrons are stopped, and in this way the voltage, negative voltage, minus side is increased, the current become less. At a particular negative voltage, the current becomes 0, the last electron is also stopped. So the current becomes 0. But what we find that it is the same potential what was used for intensity 1. Now again we do this experiment with intensity 3. With intensity 3, initially when we increase the potential, the current increase and becomes saturated. But when we decrease, then when the potential is negative, the current start decreasing. First, some electrons stop. More voltage, more electrons stop. More electrons stop. More electrons stop, and at a particular voltage, the last electrons which was having maximum energy, that also stops. The electron with maximum energy stop at that particular voltage, then the current becomes 0, and that voltage is here V0. So this also, when we are increasing the negative potential, the current goes on decreasing and becomes 0, but it is the same potential. So what I find that we are increasing the intensity, but stopping potential do not change. What changes? Answer, current do change, but stopping potential do not change. Now we have to make an interpretation of this. What we are changing, what we are not changing? Answer, we are changing intensity, we are not changing color of the light. That means frequency is made common. Here, what is changing and what is not changing? The current is changing, but stopping potential is not changing. That means current is related to intensity and stopping potential is related to color. I told you we have not changed the color. Stopping potential has not changed. So stopping potential got related to frequency, the color. Intensity is changing and photocurrent is changing. So current is related to intensity, color is related to stopping potential. Color means what? Frequency. Frequency related to stopping potential here. Okay. Now, what is the indication of stopping potential? Stopping potential is indication of energy. The last electron which stopped, it was having certain kinetic energy earlier, say 10. This negative potential give it an energy minus 10. So now what will happen? 10 and minus 10, the energy becomes 0, it does not move. If it give energy of 9 and this is having 10, it will go. When this has become 10, and how much is this energy? This energy is E into V naught. So this depends upon what? The potential applied here. And what is potential? Potential is work done on the unit charge. Potential itself indicates the work done or energy. So this is indicator of kinetic energy of the electron. Please remember, what is stopping potential indicator? Stopping potential is indicator of the kinetic energy of the electron which is emitted. How? You will say it is indicator of the potential energy, because this is formula for potential energy. That potential energy is what? This charge into potential. Okay, when we throw a ball upward, here it has got kinetic energy. When it reaches here, the kinetic energy has become 0. And what it has? Potential energy. And their sum is same, whatever sum is here. Here we find it has kinetic energy and potential energy is 0. Here kinetic energy is 0 and the full energy is potential energy. And this we have studied in gravitation chapter, that this potential energy here is equal to kinetic energy here. The same thing happens in all the cases whenever in a motion there is a conversion of potential energy into kinetic energy. So here electron is having kinetic energy and it moves here. Here we apply voltage V and it stops. Why it stops? Because the similar amount of potential energy with negative sign has been given to it and the total energy has become 0. How much energy is given to it? The same amount of kinetic energy. So, how much is the kinetic energy? Whatever this potential energy, negative potential energy given to it, which can stop it. And how much is this energy? This is E into V naught. So, what should be the kinetic energy of this electron which has stopped? Answer, E into V naught. तो इसकी kinetic energy E into V naught थी, जिसको इस V naught ने रोक दिया. तो ये हमको kinetic energy का measurement देता है. तो पोटेंशियल एनर्जी काइनेटिक एनर्जी के बराबर होती है, इसलिए काइनेटिक एनर्जी ऑफ इलेक्ट्रॉन हमें कितनी लेनी है? E into V naught. This is measurement of kinetic energy of electron, V naught. Okay, so remember, intensity gives the current. Current means number of electrons which are coming out. But V naught gives us energy with an electron, kinetic energy when it goes out. Okay, now we go to the third part. Here, what is the conclusion? We will find the conclusion first. Why intensity 1 and intensity 3? This is a 100-watt bulb and this is a 500-watt bulb. Both are stopped by the same potential. Why? The wave theory does not have answer to it. Wave theory says that 100-watt bulb has got magnitude this much, 100 watt. A 500 watt has got magnitude this much. This is amplitude for 500 watt, this is amplitude for 100 watt, so this should have more energy. If it has got more energy, then to stop this we should have a higher value of minus V, but we don't find here higher value. The same potential stops this which has stopped this. That means our assumption in wave theory that change in amplitude changes energy of the electron, that assumption is wrong. That assumption is wrong. We cannot explain why it is stopped at V0. But photon theory explains it. The quantum theory says that the photon which comes with the light, in case of I1, in case of I2, in case of I3, photon is same. Because it has got the same color, it has got the same frequency. If it has got the same particular value of frequency, the energy of each photon is same, and therefore whether it is given by the bulb of 100 watt or by 500 watt, each photon has got similar energy, and when this photon strikes the electron, it will give the same energy. Then what is the difference between the photon of first bulb of 100 watt and photon of the 500 watt bulb? What is the difference? The answer is, first bulb with 100 watt yellow color or green color will give green photons 100 numbers, 100 number. Each number will give 1 unit of current. So how many units of current will be there? 100 units of current. The second bulb gives 500 photon at a time. 100 watt was giving 100 photons, 500 was giving 500 photons. So the number of electrons released 500. But what will be the energy of an electron? In first case, energy is equal to a green photon's energy. In second case, energy is equal to 1 green photon energy, because the photon is not changing its color, it's not changing its frequency, it is not changing its energy according to quantum theory. The green photon has got the same energy. One photon interact with one electron, it will give its energy to electron. So green photon gives energy to one electron, it comes out. With how much energy? Answer, green energy. 100 photon, 100 electron, each electron green energy. 500 watt bulb send 500 photon, 500 electrons are released, but each electron has got how much energy? That green energy. Is there any change in energy of any particular electron? No. All electrons have got green energy. That energy is not energy equal to blue, which is a larger energy. So when we change the intensity, we are increasing the number of photons more. That will take out more number of electrons, but individual electron has got the same energy. That is why if there is a electron released by 100 watt bulb, 100 electrons are released, a push by 5 volt or a push of minus 3 volt will repel all. No electron can move here because the green is stopped by minus 3 volt. So all greens are stopped by minus 3 volt, whether they are 100 in numbers, whether they are 200 in numbers, whether they are 300 in numbers. All are stopped by minus 3 volt. So, but the current will be different. When there is no voltage applied, the current is 100 for 100 watt bulb and 500 for 500 watt bulb. So that is why the current is different, but energy of each electron is same, but because all electrons belong to a particular frequency and we are not changing frequency. So here I should write frequency constant, and this makes this constant V0 1 value. Okay, so wave theory did not explain, but photon theory, 2 numbers, 10 numbers. This is current small, this is current large, but this has got energy green, this has also got energy green. So there is no difference in this energy and potential stops this. In both the cases, this potential can repel it. Okay, so this is the case. Now we do the other part. The other part says here again. Now I change this variation in different style. I take all the bulbs, say 200 watt. All the bulbs 200 watt, but their color is different. It starts from red, yellow, green and blue. Okay, I keep on changing the bulb. What I am changing and what I am not changing. What I am not changing is intensity because all the bulbs are 100 watt. What I am changing is frequency, red, yellow, green, blue, violet, indigo, like that. Okay. Now with each I do my experiment. First I keep the potential difference 0. Allow the current to flow. Then I make it positive. Then I make it negative and take the observations. See the observations, how it changes. This is frequency 1. Okay, when I increase the current, when I increase the voltage, the current increase and then it becomes saturated. Okay. When I decrease the voltage between the plates, the current goes on decreasing and at a particular potential, stopping potential, the current will become 0. So this is the same graph I got. Now I change the color. I change the color and again increase the voltage positive. The current increase and it becomes saturated. But it is same value of saturation. Okay. When I decrease the voltage, it decrease, but at this voltage it does not stop. It goes up further. At V1 I am not able to stop it. I have to increase the voltage up to V2, then only I could stop it because the color is different. Okay. For the third color, when I increase the voltage, the current increase at the same value, it becomes saturated. But when I decrease the voltage, then it decrease and finally becomes 0. But to make it 0, I have to increase the voltage beyond this. अगर ये 3 वोल्ट पर -3 वोल्ट पे 0 हो गई थी तो इसके लिए मेरे को -4 वोल्ट करना पड़ा और इसके लिए -5 वोल्ट करना पड़ा, क्योंकि इनके कलर डिफरेंट थे। ओके, तो ये ग्राफ बना फिर से फोटो इलेक्ट्रिक करंट और वोल्टेज। अब क्या चेंज हो रहा है, क्या नहीं चेंज हो रहा? तो इंटेंसिटी कांस्टेंट, कलर और फ्रीक्वेंसी changing. Constant frequency is changing. In the graph, what is constant? Answer: in the graph, for all the colors, the saturated current is constant. So, current is constant. Frequency changing. What is changing? Stopping potential is changing. Stopping potential keeps on changing. So stopping potential is related to frequency and current is related to intensity. Same reason. If the intensity increase, this is increase. Now, if there is same intensity, then according to wave theory, for the same intensity, the power, the energy should be same. But here we find the energy is different. Wave theory could not explain that. If the intensity is same, the amplitude is same, why the energy of electron should be different? No explanation in wave theory. But the quantum theory says that each photon has got energy according to its color, and we are changing the colors. When we change the colors, then energy go on increasing, and therefore we need more and more negative voltage to stop the electron. So energy is related to frequency, not related to intensity. There is a proof. What is the proof? We have used same 200 watt bulbs for the three colors. If their intensity is 200 watt, their current should be same, and our experiment shows that. See, whether it is this color or this color, the current is same. Why? Because intensity is constant, so current is constant. So it is proved that energy is related to frequency and not related to intensity. Intensity is related to amplitude according to wave theory. So with the same amplitude we find different energies, not according to wave theory. But quantum theory says we are changing photon. One is red photon and one is blue photon. Red photon has got less energy, blue has got more energy. So energy is according to color or the frequency and not according to amplitude. Wave theory fails here. So this is explained by quantum theory, and wave theory could not explain it. So these are the two things. So here I will write what is our finding from here. So our finding is energy of electron is proportionate to frequency and not intensity. This was again energy of electron is not related to intensity. So these are the two things which were blow to our wave theory, which used to say that it is intensity which decides the energy. They say no, it is frequency of photon which decides the energy and not intensity. And this we have seen in both these cases. This was proved by this experiment. So Hertz and Lenards experiment, what is the result it has given? It has given that energy of electron is proportionate to frequency and it is not related to intensity. So this was a milestone which proved this result. So according to this, we could decide that quantum or photon nature of light is like a material, and the light is having a quantization. What is that quantization? That each photon has got certain energy, and energy of a photon that is given by h nu. That is energy of a photon. E is equal to h nu, and the number of photons, if there are n number of photons, the total energy will be n into h into nu. So this is energy of the photon. Now there is a concept of threshold frequency. Here we are sending light from here with, we put this light of different colors. I will start with, say, ultraviolet light. Then ultraviolet light which has got a very high frequency, very high energy. Then decrease the energy by decreasing the frequency, and we come to violet, indigo, blue, green, less energy. What we find, the current has become less. Okay, we make a graph. This is, say, current, and this is frequency. At this high frequency, we see so much current coming this point. We decrease the frequency. This was with ultraviolet, this is with violet. With violet, we do not get so much current, we get little less current, this much. Okay, then V, I, B, violet, indigo, blue, violet, indigo, blue, green, yellow. Like this, we go on getting the current with different frequencies, this way. Okay, let us say this is high frequency, this is ultraviolet, this is violet, this is indigo, this is blue, and VIB, and this is green, this is yellow. How much is the current at yellow? Zero current. And if we give it red, then what will happen? Answer, there will be no current. What does that mean? If I give it yellow current, there is how much current? Giving it yellow frequency, there is zero current. This I have observed here. In a particular, for a particular metal, when I put that metal here and bring the light from here, all these colors are giving me the light, but up to green, but when it comes to yellow, which is a lesser frequency, there is no current. I say, maybe my bulb is smaller. मैं फिर अपने बल्ब को बड़ा कर देता हूँ. 100 वॉट की जगह मैंने 200 वॉट कर दिया, और जब 200 वॉट कर दिया तो मैंने ये सोचा कि 100 वॉट इतना एम्पलीट्यूड देता है तो मैं 200 वॉट दे देता हूँ, और 200 वॉट मुझे इतना एम्पलीट्यूड देगा। आई फाइंड नो करंट। फिर से मैंने बल्ब चेंज किया एंड नाउ आई पुट इट 500 वॉट। सो मच एम्पलीट्यूड, सो मच एनर्जी, बट व्हाट कलर? येलो। विथ 500 वॉट no electron comes. I put it 1000 watt. So much amplitude. But color is same yellow. Not a single current. Yellow में भी 1000 watt में भी करंट नहीं आई। इतनी इंटेंसिटी इंक्रीज कर दी पर बिल्कुल करंट नहीं आई। ओके, देन आई डिड अनदर थिंग। अब मैंने क्या किया, ये सब बंद करके एक लाइट ली विच इज ओनली 10 वॉट लेजर लाइट, 10 वॉट ओनली। 10 वॉट पर इसका कलर जो लिया दैट कलर इज ब्लू। जैसे ही 10 वॉट ब्लू की एक रेव यहां पर आती है, एक, आई फाइंड देयर इज ए करंट हियर। What is the difference between blue and yellow? Answer, there is a difference of frequency. So, who is responsible to give more energy to electron? Is it amplitude or is it frequency? The answer is, when we change the frequency, electron gets the sufficient energy. If we change the amplitude, electron does not get energy. So, who is responsible for energy? In the light, whether it is intensity responsible or whether it is frequency responsible. The answer is, it is frequency which is responsible. How it is related to photon? The answer is, in wave theory, our explanation was we are increasing the amplitude of the wave front. And it should get more energy, which has failed, it has not given more energy. The photon theory says that each photon has got a packet of energy, and that packet when falls on one electron, the energy is transferred to electron. How much? H nu. One photon cannot be cut into two. Therefore, that energy cannot be cut into two. The whole energy will be given to electron. Whose energy? Photon's energy. And how much is that? H nu. Complete 1 H nu, 2 H nu, 3 H nu, or this energy will be equal to n H nu, where this n is a whole number or integral. This cannot be fraction. If n is an integral number, then it is either 1 or 2 or 3 or 4. That means H nu is the minimum energy one photon has. It cannot be cut. And what does the wave says? Wave is a continuous increase of level. The wave front is a continuous increase of level. The energy will become 1, 2, 100, 150, 1000, 1050, 5000. We can go on increasing with the wave. The level will go on increasing if it is a wave. And if it is a photon, it is H nu or 2 H nu or 5 H nu, whatever is in one packet. And that is decided by its color. What we have seen in this experiment, इसमें हमने ये देखा कि लाल कलर से या येलो कलर की एनर्जी से इलेक्ट्रॉन नहीं निकला। हमने उसकी वॉटेज बढ़ा दी, 500 वॉट तक कर दिया, 1000 वॉट तक कर दिया, पर इलेक्ट्रॉन नहीं निकला। क्यों? क्योंकि हमारा ये कहना था कि एम्पलीट्यूड पर तो एनर्जी डिपेंड ही नहीं करती। जब तक वो येलो कलर है, उसके पैकेट्स येलो कलर के हैं, हर पैकेट के पास एनर्जी 2 है, तो एक इलेक्ट्रॉन को एक पैकेट ही स्ट्राइक करेगा, एनर्जी 2 ही देगा। आप 100 पैकेट भेज दो 1000 पैकेट भेज दो, हर पैकेट एक एक इलेक्ट्रॉन को हिट करेगा, हर एक को 2 एनर्जी मिलेगी, 2 एनर्जी में वो फ्लो नहीं होगा, मेटल के बाहर नहीं आएगा। उसको मेटल के बाहर आने के लिए 3 एनर्जी चाहिए, वो कौन देता है? ब्लू कलर। तो ब्लू कलर का एक सिंगल फोटोन भी आएगा, एक इलेक्ट्रॉन को हिट करेगा, उसको बाहर निकाल देगा, एंड दैट विल फ्लो करंट। सो फोटोन और द पैकेट, that is the unit quantization of energy. This is quantum theory, that light energy is in the quantums, photon, and when the photon falls, the whole energy is transferred to electron. The energy given by light to electron does not increase continuously, it increases in steps. One step is 1 h nu, and when this h nu has the level more than work function, then only it will come out. Now this nu, if this nu is, again we come to this, if this nu is less than a particular value, suppose at yellow 1 electron comes out and before yellow, for red no electron comes out, then what we say, yellow is that particular frequency at which the electron start coming out. The frequency should be more than this, then this frequency will be known as threshold frequency. Threshold means what? किनारे की, एक किनारा, इस तरफ की जितनी फ्रीक्वेंसीज हैं सब इलेक्ट्रॉन को निकाल सकती हैं, इधर की जितनी फ्रीक्वेंसीज हैं कम है, कोई भी फ्रीक्वेंसी इलेक्ट्रॉन को नहीं निकाल सकती। तो ये वाली फ्रीक्वेंसी क्या है? थ्रेशोल्ड फ्रीक्वेंसी। सो थ्रेशोल्ड फ्रीक्वेंसी इज दैट मिनिमम वैल्यू ऑफ फ्रीक्वेंसी which can give sufficient energy to electron so that it comes out from the surface. अब ये डेफिनेशन, एक और चीज की भी डेफिनेशन है, ये डेफिनेशन है वर्क फंक्शन की। Work function is the energy required to bring out one electron from the surface without giving it any kinetic energy. निकलेगा, रुक जाएगा। और threshold frequency, this is frequency of that photon which contains energy given to electron, due to which it will come out of the surface and stop here. That means the energy contained by photon of threshold frequency is equal to work function. So here we will write the definition. What is threshold frequency? Minimum frequency with the threshold frequency, how much will be the energy? The answer, this energy will be h nu naught. This threshold frequency, we give a sign nu naught. So h nu naught is the energy of that photon, and I explained you that this energy should be equal to work function. This. So this is another important equation, and this is another argument which cannot be explained by wave theory. If there is a yellow light which is just not able to take out the electron, we increase the amplitude We increase the amplitude. Why its energy is not increasing? Wave theory has no answer to that. But quantum theory do have. They say its frequency is less, not sufficient to give energy. If we increase the frequency, the energy of the packet of the photon will increase, and one photon strikes one electron. That energy is now sufficient to eject the electron. So, with help of this photon theory or this quantum theory that was able to explain all the phenomena which are happening here, which we have seen by these graphs. So, this establishes photon theory or quantum physics compared to wave theory. Now, we are in a position to write the points which clear-cut indicate which were the points of this experiment where wave theory failed and quantum theory proved the experiments. Okay, these points are as this. So, according to wave theory, higher amplitude is higher energy. But this experiment showed that larger amplitude could not give higher energy. That is number one. Number two, the same intensity but different frequencies has different energy. Why? This could not be explained by wave theory because wave theory believed in the amplitude. Then, threshold frequency concept. This was very clear in this experiment that less than a particular frequency cannot eject one electron. And even if we increase the amplitude many times, this could not be explained by wave theory. Third thing, concept of wave front. You see, in the waves, this wave front is coming, not a photon, a wave front surface. This will come on the metal, absorbed, energy absorbed to one electron or to all the electrons. Answer, the wave front comes to all the electrons, giving energy, small energy to each electron. Second wave front, more energy. Third wave front, more energy. Fourth wave front, more energy. And in this way, energy goes on accumulated. A time will come when this energy of each electron has become larger than the work function. Then all electrons should move out. But this does not happen, actually. What does not happen? The answer is the moment light comes, the electron is ejected out. It does not wait for accumulation of energy. The process of electron ejection is instantaneous. It does not take time at all. It is just like a bullet hits one electron and that one electron jumps out. So a packet comes here, that electron comes out, rest of the electrons not affected at all. So this matches with the photon theory and not with the wavefront theory. And wavefront theory should eject all the electrons at a time, a large number. But a laser light jumps out, able to jump out one electron, because it is sending photon, 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 electron, 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 not like a wavefront. So quantum theory says no wavefronts, only packets of photons which come like this, interact with one electron, one photon, one electron interaction. Wavefront say a surface comes here, gives energy to all the electrons. What does this experiment proves? This proves that the moment a small light comes, one electron goes out, and the the wavefront, it should take certain time. According to wave theory, it will go on accumulating, giving energy, distributing to all. But it does not wait. It comes out immediately according to photon theory. So photon theory is correct because of the timing. So, but the experiment shows that ejection is instantaneous and not for a longer time or it is neither for a large quantity, which is contrary to wave theory. So all these three arguments proved that wave theory is not sufficient to explain the photoelectric experiment. In the science, we never say something is wrong or right. The wave theory is not correct, is a failure. This is not a correct statement. The wave theory was inadequate, or it was a failure to explain the experiment, photoelectric experiment. This is correct statement. Inadequate, because there are so many things explained by wave theory, like interference pattern, diffraction, making of fringes. All these things which were explained on the basis of wave theory could not be explained by photon so efficiently, and wave theory was able to explain them. So there, photon theory was a failure and wave theory was a success. Nowadays we are trying to explain that also with photon theory. That is a different thing. But the character of light is the waves as well as the quantums. This experiment shows the quantum nature, which can be explained only because of photons having a particular value of energy in one photon. That is property of photon in pieces. One photon, one piece, other photon, other piece. Each one is having a quantity of energy h nu, and the total energy is integral multiple of h nu. And this fails that continuation of the energy like in waves. But the other things were showing the waves and supremacy of waves. So what is the actual nature of the light? So the conclusion is, we should not divide this universe into two natures. Yes, and if you divide it into two natures, one is the nature of particle and one is nature of the wave. If you divide, then we will say light has got both the natures. Okay, so light has got one nature which contain both the natures, and we call it dual nature. Then how we explain it? Okay, we saw the different incidents. When the light is traveling in a single medium, when the light is traveling in a single medium, then it shows wave nature. It goes in the wave fronts, in the waves, and there, when it passed through an opening, same medium passed through an opening, because of its wave nature, it shows interference pattern, superposition. Correct? But when there is an interaction between a material and the light, a light strikes a metal, electron strikes a metal and a photon is ejected. Whenever there is an interaction between light and the material, then it shows its material nature, its photon nature. So, once again, when it is traveling in a single medium, it shows waves nature, and when it strikes a different medium, then it shows its photon nature. So light has got both the nature, it uses its nature whatever is required. जैसा सामने मिलेगा वैसा वो बिहेव करती है. सामने सॉलिड मिलेगा, सॉलिड जैसे बिहेव करेगी एज ए फोटोन, और सामने इसको एक ही मीडियम मिल रहा है, इट हैज टू ट्रैवल, इट विल ट्रैवल लाइक ए वेव. So let's leave it to the light and we study that it has got both the natures. Thank you.